Hello friends, this is Jim, Science Talk. I want to bring you this report about involving clean energy. Clean energy is vital, but still not enough. Basically, there's some problems that clean energy from wind and sun, as an example, cannot solve. And two new studies look at this. Okay. So let's especially if humans want to keep the warming between 1.5, no more than 1.5 by 2100, or at worst 2 degrees C by 2100, let's consider the following. One new study outlines the problems for people who want to provide the cement for tomorrow's cities, the steel for new structures, and the long-distance transport of heavy goods. Freight shipping and air travel alone account for 6% of all carbon dioxide emissions that contribute to global warming. The cement and steel industries release up to 1.7 billion tons of greenhouse gases a year. Now, electric cars may be on the road in increasing numbers, but you still have to make those vehicles. Now, maybe you might be able to recycle some existing steel, okay, but that still requires energy to do so. You still requires energy to get the ores to manufacture the parts. So electric cars may be increasing, but we still have heavy diesel trucks, for thousands of miles. It's a little difficult when you're hauling, basically, 25 tons of whatever, to have that run on electric power. The power's just not there. So for some deliveries, there's no substitute for liquid fuel. And we're not even talking about trains. How much cargo is shipped on trains? You need the big heavy diesel engines to move those things. A second new study confirms that humans already have the know-how to capture CO2 as it's produced and combine it with hydrogen from water to make high-quality liquid fuel. Now that's interesting. Notice what they say, combine it with hydrogen from water. They're not saying combine it with water. If you combine CO2 with water, you just make carbonic acid, which is, it's an acid. It's weakly dissociating, but still it's an acid. And that's what's happening in the oceans. With decrease in the pH of the oceans. They're basically saying remove the hydrogen, so you have to use some electrolysis procedure, and you combine the hydrogen with the CO2 to make some basic fuel, liquid fuel. And basically CO2 and hydrogen, you're basically making a carbohydrate, really, is what you're doing. However, this technology is still in the laboratory stage, it's still in the developmental stage, and of course the challenge, like everything else, is to get it to large-scale production and to lower the cost in doing so. Both studies do look at the larger picture. Researchers have repeatedly shown that, on paper, renewable sources could provide all the world's electricity. On paper. Renewable sources can provide all the world's electricity. But we're not talking about transportation. And even if that were to happen, it doesn't stop all carbon emissions because we got planes and trains and trucks and so forth. U.S. scientists report in the journal Science that they looked at what they call the tough nuts, yet to be cracked, air travel, long-distance freight traffic by truck, ship, or train, and the making of steel and cement, which are energy intensive. They also looked at the range of new possibilities that have begun to emerge in the laboratories, including renewable airline fuel. Now that would be interesting. So Ken Caldera of the Carnegie Institution states, taken together, these tough nut sources account for a substantial fraction of global emissions. To effectively address them, we will need to develop new processes and systems. This will require both development of new technologies and coordination and integration across industries. His co-author, Steve Davis of the University of California, Irvine, said, for better or for worse, the long-lived infrastructure built today will shape the future. We're making good progress on things like the cost of solar panels and electric vehicles, but we need to start tackling the more difficult sectors as well, namely the steel, cement, airline, truck, train, ship. A second U.S. team writes in the Nature Climate Change Journal to introduce what could be a new buzzword, electrogeochemistry. There is an argument and wide-scale investment to back it that biofuels based on ethanol converted from crops or plantations or just burned in power stations could deliver reliable energy. Now, a couple words on that. Ethanol, why did the price of corn spike? Because a lot of the corn, instead of being used for livestock and human consumption, was set aside for to get ethanol, and so that meant there was less corn available for consumption, so the prices spiked up. I personally would not be in favor of that. Now, if you can take vegetative material that's going to be discarded, that's not going to be utilized by animal or people or what have you, it's going to end up in a landfill. If you want to take that vegetative material and have fermentation processes undergo and you get ethanol from that source, that is a good way to go. That's how I see it. There's a second argument that's yet to be tested at scale that the carbon dioxide from biofuel exhaust could be captured and buried to keep it from entering the atmosphere. In other words, sequester it into the ground. I do not know much about that to really make a comment other than, how are you going to capture it? A lot of industries have long fought having put scrubbers into the smokestacks to capture, sulfur dioxide, nitrous oxide, CO2, and so on. They've long fought that. So you're going to need to set up some scrubbers mechanisms, devices. I'm not sure about that. And when you sequester, how are you going to sequester it into the ground? Are you going to take that CO2 and combine it with something and have it in liquid form? So that needs to be, I think, sorted out. I still say that if you take the vegetative matter that is going to be discarded as waste anyway and ferment that to get your ethanol, that's probably your best bet. Now, Greg Rao from the University of California, Santa Cruz argues that electrolysis of saline water could generate hydrogen and oxygen. Reactions between easy-to-obtain minerals could yield a solution that absorbs carbon dioxide from the atmosphere and turns it into a carbonate that could stay in the seas and reduce ocean acidification. Now, yes, carbonates, calcium carbonate, as an example, is a good buffering system. So that is quite true. That is quite correct. The problem is to implement electrolysis of saline water, seawater, is energy intensive. So here we go again. You're trying to use energy here. I was having a discussion with someone about why not just have desalination plants to address the issue of fresh water. And there's several reasons why it's not on a more wide-scale basis. It's energy intensive. It requires a load of energy to do. It's extremely expensive. And it's extremely expensive. It's energy intensive, and you need huge amounts of land to set up the facilities. Now, if you go to a place like Saudi Arabia, they've got desal plants there. Well, they've got the money. I spent time at the West Indies lab in St. Croix, and there was a little mini desal facility at that at that location that served just the lab. But the lab was a small group. You had about 6 or 7 scientists, a little bit of support staff, and like about 20, 25 students at most. So, but it was a lot to run that. So it requires a lot of energy to run, and it's very expensive, and it's difficult to implement on a large scale. So you have the same issue with electrolysis. It would just is the energy issue, which then of course leads to pollution issues. But the idea of taking the CO2 and turning it into a carbonate, yeah, that on paper that's make perfect sense. Hydrogen is already a vehicle fuel. So from the materials in hand, chemists could make other fuels. And at the end of the process, could be less CO2 in the atmosphere. So basically implying that, we can end up with negative emissions. Of course, this is all being developed, has to be perfected and then implemented on a wide scale while reducing the cost. So this is basically Professor Rao's team that's making all these observations and comments. The researchers reason these electrogeochemical methods could, on average, deliver 50 times more energy generation and carbon removal from the uncertain and land-consuming approach involving biofuels and carbon capture. Such approach is still in the infancy. Okay, that sentence there about land-consuming approach, that's basically what I was just alluding to when I talked about hydrolysis, desal plants, and so on. Dr. Rao says it's early days in negative emissions technology. You need to keep an open mind about what options might emerge. We also need policy that will foster the emergence of these technologies. Basically, need politicians to get on board and to say, yes, we need to do this, and then provide the funding so this research can take place. But just wanted to bring you this report of active research to try and address the climate issue and the CO2 issue and so forth. So I know a lot of my reports only seems to be like gloom and doom kind of stuff, and it is dire, but at the same time, it's only fair that I bring to you reports where what the research that's out there that's being done to try and address this. Yes, I bring you reports on what's happening and where it's going to go, but hey, I just did the report on China reducing its emissions, at least in China, and I'm bringing you some of the new stuff here. So that's about it for this video. And thank you for your time, and we'll talk soon. Hello folks, this is Jim asking for your help. I want to grow this channel significantly. I want to increase the number of people who subscribe to my channel. I want to increase the number of people who are supporting patrons on Patreon for this channel. Patreon.com/Science Talk with Jim Massa. I do not receive funding of any sort from anyone. So the information I share with you is the information as found published in the peer-reviewed journals. No propaganda, no BS, just the science, and of course I give you my interpretations and analyses based on my experience as a scientist. So please tell others of the work I do here, tell others of my channel. Share my videos, post them on other social media platforms. But we need to disseminate this information to more and more people, to a wider audience. And I need your help in doing that. For those of you who are already patrons and support me on Patreon, thank you. Thank you for your support and continued support. Together we can do this. So you'll find details in the description box below how to support me on Patreon. And thank you. Thank you for your help. Thank you for your continued support. It does mean a lot to me. We can do this.